Have you ever wondered how your favorite streaming service just works? How it never seems to buffer? Or how cloud apps respond in a blink? Well, it's not magic. It's the result of this quiet, incredible revolution. A story of how the huge, complex computer networks that run our entire world basically grew a brain. So that's what we're going to dig into. The journey from a world of manual, device-by-device labor to one of intelligent, automated machines. Let's just dive right in. The story of how networks evolved is really a tale of two completely different worlds. On one side, we started in a place that was super rigid, slow, and totally manual. Every single change required a person typing on a keyboard. But now, we're arriving in this new world that's automated, agile, and, well, intelligent. The big question is, how in the world did we make that incredible leap? So let's start in that old world. Try to imagine a network where every single router, every switch, was its own little island. It was managed completely by hand, one device at a time. I mean, that was just the reality of traditional networking. To find its way around, each router had to rely on its own private map, which is called an IP routing table. You can think of it like a driver using an old-school paper map of just their local neighborhood, with absolutely no access to a GPS that can see the whole city. Every turn, every single decision was based on this really limited, isolated little picture of the world. Okay, so how did a router choose the best path using only its local map? It followed this really strict three-step logic. First, it always looked for the most specific direction possible. Think, go to 123 Main Street instead of just go to Main Street. Now, if it had multiple specific routes, it would then trust the most reliable source, kind of like a recommendation from a trusted friend. And only then, as a last resort, would it even think about the cheapest or shortest path. So specificity always be trust, and trust always be cost. Now try to imagine this isolated decision process happening at the same time on thousands of individual devices all across a network. And for a while, this system of independent islands actually held up. But as our digital world just exploded in complexity, driven by things like the cloud and video streaming, the cracks really started to show. And that brings us to the breaking point. With networks getting bigger and bigger, and cyber threats getting more and more sinister, this one device at a time approach it couldn't keep up. The manual model was pretty much on the verge of collapse. So this put every network engineer in a really tough spot. The critical question became, how can you possibly configure and secure a massive, sprawling network when you have to do it one device at a time by hand? The old way just wasn't going to scale. The insecurity of the old tools just perfectly captures this whole crisis. For instance, a common tool called Telnet sent passwords in plain text, like totally visible to anyone snooping on the network. The urgent shift to encrypted tools like SSH was a necessary band-aid for sure, but it really highlighted the deeper problem. Managing security device by device was a losing battle. And this security arms race wasn't just for wired networks. In the wireless world, we saw a similar frantic evolution. We went from the easily cracked WEP protocol all the way to today's super robust WPA3 standard. We were just constantly playing defense, always reacting to the latest threat because the system itself was too rigid to be proactive. So the solution to this whole mess wasn't just better security protocols. It was a completely revolutionary new architecture. It was time to stop managing thousands of separate little islands and instead give the entire network a single, centralized brain. This revolutionary idea was called software-defined networking, or SDN. And the core concept was actually pretty simple but totally profound. Take the intelligence, the decision-making part, out of all the individual devices and put it all in one central, software-based controller. The way SDN works is by literally separating the network's brain from its muscle. The brain, or the control plane, is that new central controller that makes all the smart network-wide decisions. The muscle, or the data plane, is all the physical routers and switches. They now have one simple job: forward packets as fast as they can based on what the brain tells them to do. The result was this massive architectural shift. We went from a world of thousands of devices, each with its own tiny integrated brain, to a whole new model with one powerful central intelligence that was in charge of an entire army of simple, efficient muscles. Okay, but a central brain is great and all, but it's kind of useless if it can't talk to the body, right? So how does this new network brain give its orders to all those muscles? Well, the answer lies in a brand new language of automation. The answer is a universal language called an API, or Application Programming Interface. Maybe the best way to think about it is like a waiter in a restaurant. You don't go into the kitchen to tell the chef how to cook your meal. You give your clear, structured order to the waiter. That's the API, who then communicates it to the kitchen in a way they understand. It's a language for machines to talk to each other without any mistakes. And what's so wild is just how simple this language is. It's built on a handful of basic verbs you already use every day on the web, like get to retrieve information, post to create something new, and delete to get rid of it. These few simple commands are the building blocks for all of modern automation. It's pretty cool. And then you have these specialized tools that use this API language to do all the heavy lifting. A great way to think about it is like this. A tool like Terraform is the architect. It builds the house, the foundational infrastructure. Then a tool like Ansible comes in as the interior designer, configuring everything that goes inside that house. So what happens when you put all these pieces together? You've got the central brain, this universal API language, and these powerful automation tools. Well, you get to the final stage of this evolution, a network that can pretty much manage itself. This whole self-management thing is powered by a process called an AIOps loop. It starts with the network constantly collecting real-time data. Then, an AI model analyzes this data not just to find existing problems, but to predict future ones. When it spots a potential failure, the AI uses an API to trigger an automated fix, which is then carried out by a tool like Ansible or Terraform, all without a human ever lifting a finger. So what this really means is we're shifting from a world where networks are just passive tools that we manage to one where they are active, intelligent partners that can anticipate and even prevent their own failures. And this leaves us with a pretty fascinating question for the future, doesn't it? As we automate away all the manual labor of clicks and commands, what's our new role? It seems like our job is shifting from operator to architect. We're no longer just managing the machine, we're designing its intelligence. The new frontier isn't about configuring networks, but about defining the very intent of these powerful autonomous systems. And that changes everything.